Good evening, students. I am Mrs. Parvati, PGT Physics, Holy Hearts Educational Academy, Raipur, Chhattisgarh. Again, I am here with the new topic here, Dielectrics and Polarization. We have done some dielectric meaning. It is nothing but an insulating medium. Insulating medium here. Polarization. What is the meaning of polarization? Whenever you take a dielectric, first of all, conductor we will say. We will take a conductor, we will keep it in uniform electric field. Then what happens? Just now we have done, inside the conductor E is 0, right? The charge is induced on the either side of, this is a uniform electric field E naught, and this is the conductor, this is E naught, and due to the induced charges, the charges plus positive charge is accumulated here, negative charge is here. So a field is set up opposite to that of the external field E naught, and also in the conductor the charge lies only outside here. We have studied E is 0 inside. The net field is always 0. That is why the net field inside the conductor is always 0 when the conductor is placed in uniform electric field here. And let us come back to the dielectric. What will happen to dielectric here? The charge is polarized. Here the molecules are arranged, minus and plus charges are arranged like this here, and here due to polarization the charges are here negative and here positive charges in uniform electric field, but E naught is not equal to EP due to polarization. You know polarization meaning the drifting of charges towards the edges of the dielectric is called shifting of the charges towards the edges of the dielectric is called polarization. So the polarizing charges, induced charges you can call it as polarized charges, dense in intensity, and this are not equal here. So there is a net electric field exists inside the dielectric. How much here? E is equal to, we can say that sigma by sigma p by k epsilon naught, where k is dielectric constant. Where k is dielectric constant here. Got my point? Okay. Now there are dielectrics are two types. I think you have done in your chemistry, must be. And what are they? One is polar dielectric and another is non-polar dielectrics. What is a polar dielectric or polar dielectrics? What are polar dielectrics? These are the molecules whose center of positive charge and center of negative charge does not coincide with each other. There exists a distance between positive charge and negative charge. When there is an equal and opposite charge separated by a very small distance, what do you call it as? Dipole. There exists a dipole moment. So that is why this type of molecules are having some dipole moment. So they are called polar dielectrics. Polar means some dipole moment is existing over there here. It's clear? Example of polar molecules or polar dielectrics are hydrochloric acid HCl and water H2O. These two are the best examples of polar dielectrics. And the next one is non-polar dielectrics. What do you mean by non-polar dielectrics? The center of negative charge and center of positive charge of the molecule will coincide with each other. There is no distance between these two them. That is D is 0. We know that P is equal to Q into 2A. 2A is 0. So there is no dipole moment at all. So they are called non-polar molecules here. So examples are oxygen and hydrogen molecules. Okay. Whenever polar molecule or non-polar molecules are placed in uniform external electric field, what happens that we would like to study here. Suppose if the non-polar, I will show you in diagram here. This is the non-polar dielectric. Non-polar dielectric here. This is the non-polar dielectric. And in non-polar dielectric, here what happens here? The center of positive charge and center of negative charge are coinciding. No dipole moment here. So E is 0 here. I am not applying any external field. So E is 0. So same non-polar molecule if I placed in E is not equal to 0. They stretch. There is a distance between, see here, center of positive charge and center of negative charge are separated by a small distance. And this Because of this distance, there exists a net dipole moment in uniform electric field. So, this is the behavior of non-polar dielectric. When it is placed in uniform electric field, there creates a net amount of dipole moment. Right? Okay. Come to the polar molecules here. Here E is 0. The center of positive charge and center of negative charge are not coinciding. So there exists some dipole moment. So when you place it in external field, what happened? The stretching will be more increase in dipole moment. So that is why the molecules are stretched. The dipoles are stretched here. So there exists dipole moment here. So I conclude that the polar or non-polar molecules are placed in uniform electric field. There exists some induced dipole moment between the molecules, right? And this induced dipole moment is directly proportional to what factor? The applied electric field, that is the induced dipole moment P of either non-polar or polar is directly proportional to the electric field applied. Or to remove the proportionality sign, we will keep a constant, that is XIE, we call it as electrical susceptibility of the dielectric here. It depends on the nature of the dielectric here. Got it? Okay. So my point is, whenever a dielectric is placed in a uniform electric field, what happens? Inside the dielectric, there is a stretch of molecular dipoles here like this. So there is a net dipole moment in this way here, and in case of conductor E is 0, but here the net field is not 0. The net field is sigma P is induced here. Sigma P is equal to sigma I here. So we write E is equal to sigma P by K epsilon naught, that is equal to sigma by K epsilon naught. That is electric field developed, net electric field developed between the two plates of that is two edges of the dielectric here. It's clear when it is placed in uniform electric field. This is the direction of electric field and this is the direction of dipole. Both are same direction. Applied electric field as well as dipole moment. Both are in the same direction. This we will use it in parallel plate capacitor when it is filled with the dielectric here in next class. Okay children, see you, bye bye. Practice all these things.